In this video, we're going to write recursive methods for the AList and the AList classes. So what we're going to do is we're going to take comment out a current method that's written, and we're going to replace it with the recursive version. So we're going to work on the contains method. Remember, the contains method takes in a single parameter that is of type T and then returns a Boolean, basically whether or not this list contains this element. Okay, so I'm going to comment out the old version of the method, the non-recursive one, and we're going to rewrite this recursively. So it's going to have the same method header. Right now I'm in the AList class, so this is the class that uses an array to implement the list, and that array is called list. We also have access to number of entries. Okay, so I want to write a recursive method. So what I want to do is I want to basically look through the array recursively to find out if that list, or that array that's used to store the list, contains the element. Now, so many times what we're going to do is create a private helper method. So we will do this a lot with recursive methods. In particular, recursive methods that deal with arrays, you will often want to use a private helper method to help you accomplish the task. You don't always need a private helper method with recursion, even with recursion dealing with arrays, but you almost always do with arrays, and you often do with recursion in general. So what I want to do is I'm going to write a private helper method. And that helper method is going to take in the same entry that I'm looking for, because I still need that information. I need to know the element I'm looking for. But what it's also going to do is it's going to take in a starting and an ending index. Okay, because when we're recursively looking through an array, because the array is passed by value, just like all references in Java, the array is going to be the same array being passed to the method each time recursively. So the array isn't going to change. So instead what we do is we use parameters to keep track of the indices of where we're looking at in the array. Okay, so this is a common thing to do for, again, recursive methods that deal with arrays. Now note that we don't have to pass the array as a parameter because it's instance data. So any method in this class has access to the array. So we don't need to include it as a parameter because we're writing inside the AList class. Okay, so what I want to do is I want to think about my base case and my recursive case. So what is my base case going to be? Well, my base case is going to be, if we think about, we want to look at the array recursively. So I want to start out looking at the first item in the array. And if it's the one I'm looking for, then great, I'm done. But if it's not, then I want to solve the rest of the problem later, right? So the small piece I'm solving now is looking at a single index in the array, comparing it to what I'm looking for. And then the part of the problem I'm solving later is looking through the rest of the array. So that's my small part, and that's my part I'm doing later. And then what is my base case? When do I know I'm done? Well, I basically know I'm done when there's no indices left in the array to look at, right? So I know I'm done when I am looking at the last place in the array, or you could say when I've kind of gone off the end of the array. You could use either one as your base case. So I'll say when I'm looking at the last place in my array. How do I know I'm looking at the last place in the array? Well, it would be when my starting and my ending index met each other, right? So if I'm keeping my ending index fixed and I'm increasing my starting index one by one, so I'm looking kind of up the array, once start meets end, that's going to be my last element. So when start is equal to end, this is my base case. That's when I'm going to be done. And so then my recursive case is when start is not equal to end, or in our case it's going to be, we're going to call the recursive case as long as, or what we know is that start, is less than end. Okay. Okay, so if start equals end, what do I need to do? Well, I still have one last element in my array to look at, right? So what I want to say is, well, let's look at that item, and if list at start is equal to an entry, then hey, guess what? I found it. Let's return true. And if I'm looking at my last item in the array and it's not equal to the one I'm looking for, well, then I can return false because I know I've looked through the entire array and I haven't finished, and here I am. So I have not found that element on my array. It doesn't contain it. So that's my base case. Now let's think about the recursive case. Okay, so for my recursive case, I'm looking again at a single entry in the array. So I'm going to look at current entry is going to be list at position start. And then what do I want to do? Well, I again need to know if that current entry is the one I'm looking for. So I have to know if it equals an entry. And if it does, I can basically stop my recursion, right? Because the contains method works as soon as we find a match, we're basically done. So if it matches, then I can just return true. But if it doesn't match, then I need to keep looking. So what I need to do is I need to call this helper method recursively with what parameters? Well, I'm still looking for the same item, so I'm going to send an entry as a parameter. And then I want to increase start. So I'm basically looking, I already looked at the element at position start, so now I want to look at the element at position start plus 1. And then end hasn't changed. Okay? So this could be my recursive method. Right now I have a big error in here. Look for a minute and see if you know what it is. My big error is that I have not returned the value of my recursive call. So whenever you have recursive methods that are valued, meaning they're not void, they return something, you always have to return the value of the recursive call. If you don't do that, your recursive calls won't be linked together. Okay, so you always, when you have your recursive invocation, you need to be returning that value. Otherwise, you're just calling that method, but it's going to finish and complete and not send you back any value. So you always need to make sure you're returning that value, and that's what links the recursive calls together. Okay. Okay, so that's my helper method. Now the last piece I need is I need to figure out what values to send in as parameters. So I'm going to return, in my contains method, I'm going to return the value of contains helper. And I'm obviously going to send in an entry. But what should my starting index be? Well, remember for the AList class that our objects start at position 1. Remember, we left position 0 empty so that the array position matches the list position. So my starting position is going to be position 1. And what about my ending position? My ending position is going to be number of entries. Okay, so a couple last things we want to think about are, will this work on an empty list? Well, if it works on an empty list, what is going to be stored? We're going to send this in with 1, and number of entries is going to be 0. Okay, so this is not going to be true, right? Start is not going to equal end because 1 is going to be 1 and 1 is going to be 0. So we're going to get into the recursive case. But then we're going to try to get out the current entry, which is going to be null, and invoke a method on it. And we can never invoke a method on null. So what we actually probably want to do is we could adjust the starting and ending to make sure that we could add another base case basically saying if start is greater than end, to just return 0, or I'm sorry, return false. Okay, that would be one approach. So it would be kind of a third case here, a second base case. The other thing we could do is we can just check in our contains method if our list is empty, return false. Otherwise, then we return the value of our recursive method. Okay, so either one of those approaches would work. But you need to account for an empty list somewhere. Okay, so in the next video, we're going to take a look at changing the contains method in the AList class and making it recursive as well.